Inshallah, today I'm going to speak about one of the most important topic in distance protection relay. It is inter and overreach in distance protection relay. In this session, we'll see what's meant by the inter and overreach, and also we'll see how the interreach and overreach will happen, and why you need to consider these two important factors during design or protect our transmission line. Assume we have here this small single line diagram. We have here substation A, substation B, and substation C. The distance between substation A and B, assume 100 km, and the impedance required for protect this line, it is 10 ohm. So 10 km will be 10 ohm, and from B station to C station, again let's say 100 km, and the impedance will be 10 ohm for 100 km. And this our distance protection relay, and you know the distance relay, zone 1 is protect 80 or 85 percentage, zone 2 it is cover 120 percentage, and zone 3 it is protect 220 percentage. Okay, also we'll see why this zone 1 we needed to protect it 80 or 85 percentage. Why we don't make this zone 1 to protect 100 percentage? خلاص, why I don't make this 100 percentage, and we'll see why we don't make it 100 percentage, and we'll make it up to 80 or 85 percentage. Okay, now let's start with interreach. So how the interreach will happen? Normally interreach is having die to what? Arc resistance. Die to arc resistance. To more understanding, let's draw the Mohr characteristic. This is the Mohr characteristic. Here we have X, here we have R. This is the Mohr characteristic. Okay, assume this zone 1 and this zone 2. Now let's consider the fault is happening here. This is the fault. So this fault is happening where? In zone 1. So zone 1 should be tripped. But die to arc resistance will be have two resistance. The first resistance, this we called Z fault, right? And another one, it is arc resist or impedance die to the arc. So we have Z fault plus Z arc. So die to this, the relay will see the fault here. Example in zone 2, like this. We'll see here. So this will be Z fault plus Z arc. So die to this Z arc, the distance relay will see the fault in zone 2. So the relay will be operate in zone 2 instead of zone 1. Because the fault is happening in zone 1, the relay should be tripped in zone 1. But die to this arc resistance will be have two impedance, one Z fault or impedance up to fault, then another one Z arc. So by adding these two impedance, the relay will see the fault here in zone 2. So the interreach we can known as the interreach. The interreach, it is the impedance seen by the relay will be more than the actual value. So the interreach will be the distance relay that seen by the relay, it will be more than the setting or the actual. So this is what mean the interreach. Okay, and how the interreach will happen. Okay, so that's now we understand how the interreach and the meaning of the interreach. The interreach, this the impedance seen by the relay will be more than the actual value. Now let's see the overreach. How the overreach will happen? Normally the overreach is having die to what? DC offset. Die to the DC offset. If you draw the waveform for DC offset, will be like this. Okay, then we'll back to steady state. Okay, so here we have two things. We have DC component and we have AC component. Okay, and we know the distance relay is worked by measuring the impedance along of the line. Z will be equal V by I. But this I, it is I RMS. But in this case also we have here DC component, right? So now let's take example to to get more clarification. Now assume the fault here. Let's take this small single line diagram. The fault is happening here in zone 2. Okay, this is the fault point. Okay, this fault is happening after 20 kilometer, let's say, from substation B. Okay, now let's calculate the current. Let's calculate the current without DC offset. Now let's calculate the current or the fault current without DC offset. Okay, so I will be equal V by Z, right? Let's say the voltage in secondary will be equal 100 volt, okay, in secondary. So will be 100 divided by the Z up to the fault point. As you know, 100 kilometer will give us from substation B, A to B, 100 kilometer will give us 10 ohm. Okay, I need the value of the ohm up to the fault point, means up to 20 kilometer from substation B. So we have here 20 kilometer. All what I need this one. 10 multiplied by 20, 200. So 200 divided by 100 will be equal to ohm. So 10 ohm plus 2 ohm, how much will be? 12 ohm. Okay. So how much the value of the current of the fault current will be? 100 divided by 12 will be equal 8.33 amp. This value of the current without DC offset. Now how to find the fault current with DC component. So to find that, so let's say the IRMS, okay, IRMS will be equal IAC, means AC component. Okay, the AC component means this one, IRMS. Okay, now let's calculate fault current due to the DC component. So to find that, we will say I fault will be equal in the root like this one, IAC component square here plus IDC. IDC means DC offset square. Example, the DC component current will be, say, IDC. Let's example take 6 amp. Okay, we'll take 6 amp. Now let's see. Now we'll calculate it. Okay, so it will be like this. IAC will give us how much? 8.33. Okay, square plus IDC, how much is 6 square? Okay, so how much will give us? Will be 8.33 will be equal 10.26. okay, 10.26 ampere. Now let's calculate the impedance. Okay, with the DC component. So the Z will be equal how much? 100 divided by this value 10.26. How much will give us? 9 will be equal 9.74 ohm. So what's mean? In the steady state, the fault will trip in zone 2, right? But now see with DC offset. Due to DC offset, the impedance seen by the relay will be less than actual value, right? Less than actual. So the relay will see the fault here. So means the relay will trip in zone 1. So means the relay will trip in zone 1. The fault is happening in zone 2, but due to this DC offset, the distance relay will trip in zone 1. So this how the underreach and overreach, and also the important factor we need to consider also the CT and VT error. Also need to consider the CT and VT error. So that's why if you make it the zone 1 protect 100 100 percentage means the chance of over and under reach will be more. So that's why I make the zone 1 only 80 percentage or 85 percentage to avoid any maloperation for distance relay. Okay, so that's why I make zone 1 80 to 85 percentage to avoid any underreach and overreach. Okay, so I hope this video it's clear for you. Thank you so much.